So, the way we had our cover system before was we had to set it up beforehand. We had to set up from where and a curve basically to where we can have cover or not, and of course that can get pretty tedious in a large level. So we're going to work with that, and we're going to create a new system. And the only thing that you have to mind when creating a level is basically just use box colliders. And if you only use box colliders, then you will have an dynamic cover system like this. Okay, this is not the cover system I had before. As you can see, it also has angle awareness. Okay, if the angle is 90%, then he won't go there, but if it's lower than 9%, then he's going to go. I can stick into any collider that has any box collider basically that is on the layer that I have my work collisions, and I also have a threshold on how big must be, or the minimum the collider can be, so I can take cover from it. Okay, I can aim both ways, and if I'm in the center I can aim up and so on. And of course, since it's angle aware, we can have something like this. Okay, I can go all the way, and if it finds an angle that's higher than 9%, then that means we reached to the end of the cover, so we can start aiming from the sides instead of aiming up if it's a cover like this. So how this works: just place a box collider, okay, you only have to place a box collider and nothing else, and you have your cover system. And it will probably work if it's a dynamic box collider, so even if the box collider can move. Okay, so let's see it. We're going to encapsulate everything pretty much in one script, but we need to do a few changes on our other scripts, mainly on our character movement. Okay, if you remember, we had a lot of stuff that had to do with the cover. Remove everything, delete them, and you do not have to delete anything from here. Okay, delete all of them, and inside tick just leave handle movement normal. Now because we rework the cover system, we're not going to have vaulting for now. We're going to handle that, both vaulting and climbing, we're going to handle that differently, and you will see how. So on character movement, leave only handle movement normal inside tick and all this stuff. We won't need anything else. On handle animations, we're going to do another bit of encapsulation. Just keep all these variables you see over here, and we're also going to create this function, which is a public function, tick common, which is some common variables we want to use throughout our different behaviors, because basically when we are enable the cover behavior, we're going to select which scripts we want to run their update. Okay, so we do not have to disable, enable, and all that. The same way we did it on our previous videos, or yeah, the last stand video, not the preview one. Okay, so the common will have the animation speed. Okay, this is pretty much needed if we want to have slow motion and all that. Okay, reloading, aiming, the weapon type, stance, aim at sides, and if we want to exit locomotion or not. Okay, these are pretty much universal, and we'll probably need them in most cases we're going to create. So that's it for the handle animations. Okay, pause the video, make sure you have these functions, these variables over here, these lines and these lines over here, and of course do not forget to throw the tick common on the regular tick. On state manager, we're going to have the classic thing we are doing. Okay, public cover behavior, assign it, initialize it by passing this state manager, and further down on fixed update we're going to say cover behavior tick. Okay, if only you have a cover behavior and you're not down. Notice that we do not have it inside the dummy model because we want to enable the dummy model when we are inside the cover behavior, so we handle everything differently over there. And the last thing we need to change before going into the cover behavior is the input handler, where basically I've kept on fixed update we had a lot of stuff that had to do with the cover, so we have pretty much left only this. Okay, we do not handle anything with the pivot anymore, or yeah, we actually do, but we do it a little bit further. So you will need this thing, target state, states in cover, okay, camera properties in cover, if you are aiming and all that, because they do not have to do with the cover behavior as it is. And we should delete this. If you keep this over here, well, let's keep it, although I think it just overrides itself, so it's useless. Okay, the same stuff we have before. The other thing, we had a lot more stuff over here. Okay, if we are in cover, change pivot will be false, and if we are on left pivot or not, it's going to be controlled all from the cover direction we have on our state manager. Okay, either true or false. If we are aiming, we cannot move. This will not work though. You need to add states.horizontal and that. Okay, only this. And the rest will be the same as they were. Let's see my bookmarks. And these are the same. Okay, so we are ready now to go and see the cover behavior. Let's talk a bit about how we find the cover. Okay, and for that we're going to use our good old friend MS Paint. So we have our character over here. Okay, and we have a box collider or something. Let's actually, because it's too bright, let's throw a little bit of color. Okay, our character and a box collider. So our approach will be, we're going to use a few raycasts, and I'm saying a few because they are a few. Okay, the first thing before we are into cover, the first thing we're going to do is, of course, do a raycast to the forward of the player. Let's put an F over here so we know where the forward is. Okay, and we find a collider, box collider. Now we need to make sure that it's an actual viable cover, or it's a valid cover, because a recast is a single line. Okay, we might hit a collider that is too small, or we might hit an edge of a collider like this one, okay, which is too small for anyone to take cover behind. So yeah, it's useless. So the first thing we're going to do is test out the sides of the collider, or the size, how big it is on on the horizontal plane. So to do that, and to help us orientate, to help us a little bit with the rotations of the cover and all the colliders, because we have to do with normals and all that. So to make this a little bit easier, we're going to create a helper object that we're also going to be placing with the same rotation that has the normal we hit on the collider. Okay, so it will be not the same rotation, the opposite rotation of the normal of the collider. So we will have it, we will place a helper object looking like this. Let's fill it, yeah, something like that. Okay, so what this does, gives us the orientation of the normal of the collider, okay, the angle basically, or how much you are looking, and from over here we can start doing raycasts. So I want to have a minimum cover distance, or minimum cover size, and to do that I go ahead and create two more raycasts. Let's use something else. Okay, I take a position from the right and the left of my cover, of my initial cover helper, and not too large. Okay, we do not want to have very big sizes. Okay, just a little bit, something like this. So I do two raycasts. If one of them hits and the other doesn't hit, it's not a valid cover. That means the collider we just hit is lower, or basically the area we just hit is lower than the threshold we have. Okay, if both hit, that means it's a viable cover, so we can take cover through it. And this way you can also, if your player runs like this, okay, only the one who is going to be hitting, so that means that is not going to take it as a cover. So yeah, you won't be falling and sticking onto the wall when you do not want to stick on the wall. Okay, so this way we have our we have found a cover. How we move on to cover now? Let's click new. Let's do it from the start. Okay, our cover. Our player is now onto the cover, or let's make it green, and we also have our helper on the cover, but since our helper has tagged on the box collider, now depending on where we want to move, if we want to move left or right, we're going to place the helper. So if we are not pressing any button, that means we do not want to go anywhere, we just stay on the previous variables we had. Okay, let's say we want to move left. What we are doing, we first need to find if there is a cover left to go. So we have, if the starting position of the helper is this, okay, is this, we take a position from the side we want to move, in our case the left, and we do another raycast. We do another raycast and we see if we hit a collider, and if we did, we place the helper on that position. now of course we add a little offset, so we're not hugging the wall. We are not on the wall, we are a little bit offsetted from the wall. Okay, so we have another position towards us that we know that we are covered. What's left to do is move our player towards the direction of the helper. Okay, so this is how we move. We translate that into a direction and we add that as forces to our rigid body, and we're moving like this. So we're moving with the rigid body. However, I have closed the collider of the player and hard coded him so that he freezes his Y position, otherwise we'll fall through the floor. And we've closed the collider of the player because, yeah, in our case it's a little bigger, it's a capsule collider, and there's no need to, yeah, otherwise we will be going through the wall, and we do not want that. We do not want to have problems with collisions with the wall. Okay, especially since the capsule collider is only used for, you know, only movement purposes. Heat detection and all that will be handled differently. So, as I said, okay, we have our way to move. With this system, what we also get is that if you have two walls like this that are placed like this, or 3 or 5 or how many walls you want to have, and that is why you have to use box colliders and not mesh colliders, which you see them used a lot, but they are not really a good solution, especially for things like that. Okay, if your player is here, and wants to move this way, okay, it's going to go, and the helper, the next position it's going to find is this one. So that means he finds a box collider, that means he can move there. So he will go like this. The same thing from here, since we are doing the helper position is below, it's a little bit below our player, that means it finds this one over here, and so on and so on. And if it's at the edges, so the player is here and the helper is over here, does a raycast and doesn't find anything, that means it's not covered. And because there's a lot of cases though that you might have walls that are placed like this, or box colliders that are placed like this. Okay, and for this one I have another solution. Of course it's better if you have all your walls packed. Okay, so I place the helper here, well, looking like this actually, looking towards the wall. The player is still going to look towards the wall. So it recasts, finds a wall, it recasts, finds a wall, and I've also made a fail-safe, so you can have two-step validation. So if the first position doesn't hit anything, you can try recasting a little bit further away. Okay, so if it finds, so it can pretty much jump little areas like this that there is no there is no box collider in it. And in this case, if it falls after the second validation, then that means it's not a, it's not a cover system. Your wall is broken up. And because we use box colliders, and the box colliders some might be placed over here, but another might be placed something like this. Okay, you immediately start having a problem over here. Okay, because if the helper hits this side, then you will see that it's going to be placed over here since we have an offset, and you'll have your player looking like this all of a sudden. Okay, so that will be an error and your player might even stack. What we do in this case is simply when we hit an angle or when we hit a normal, okay, let's say this, let's say something like this, or yeah, we hit an angle, we see the difference between the current rotation of your helper, and if it's lower than a threshold, I think I have it at 45, that means it's a cover position, so we can move about this much and it changes on the wall. If it's higher, that means it's not a valid position. Now you can do this to move for 90 degrees cover positions. You can raise this threshold, but you also have to, yeah, it's you might need to write a little bit more code. And before we do all this, we place the helper. Of course, we need to check if there is a wall before we place the helper. Okay, so if your player is here, the first thing he's going to do is check from the side we want to move if there is a wall. If there is a wall, then that means you cannot move towards that position, and you also cannot cannot aim and all that. Okay, so let's see this in code. We're starting. So we're going to include this as their own namespace, so that means you also need to add that on your state manager. Okay, using cover, and there might be some variables you might want to delete, like cover percentage. I think we're not even using it anymore. Yeah, we're not. Okay, so they're going to show up when you delete the stuff you do not need. So start. If we are searching for cover, if you do not want to search for cover, just make this false by default. I have it on my inspector, on my prefab. I have it ticked, and I also have enabled to point validation. If you want to debug cover, if you want to see how this works, for example, okay, and yeah, I should have applied the prefab. All the things we've forgot to close it. All the things I've just said come down to this. The helper is the cube, and you see that the little things that he jumps around is because in the edge between it there is no box collider, so it avoids that by the things I've just said. And you see that all the jerkiness you see doesn't show on your player because we took care of all that, but it shows on the box collider works just fine. Okay, let's see it on a different surface. Okay, the player moves smoothly, and we have all the helper trying to figure out the orientation and all that. Okay, it's a pretty elegant approach. I think it might be a little bit more performance since we have a few more raycasts, but just alone that we do not have the collisions of the character movement, it counterbalances out the performance, I believe. So let's go back. Set manager, search for cover. How far ahead you're going to be looking for a cover. Initializing the cover if you have cover. Of course, cover position is not the script we had before. I've deleted that and I made it a class like this, and this will only help us getting into cover. Everything else, we're not going to use this basic for everything else. Okay, position 1, position 2, and initial hit. The initial hit we did. Minimum cover, how small, how big the minimum distance between a point to point for the cover, basically. How far you want to be placed away from wall. I intentionally left them private because I set them up from the init function. Okay, these are the values to use, so that we know exactly when you're watching the video, you know exactly what values I am using. Okay, you can make them public and use them from the inspector, and that goes for a lot of variables. Okay, offset from wall, and sample distance is how far ahead when you're moving, how far ahead the raycast should be. So if you're moving to the left, how far left? Okay, you will see in a bit. Our helper, because we have a lot of layers, and if you do not ignore layers, then that means your box colliders that are on your weapons, on your prefabs, or your pickables and all that, and on your targets or anything else you do not want to stay behind as cover, of course you need to start ignoring those layers. And because we use a bit much more raycasts, we need to have them over here. Init layer length, start position, target position, layer speed, the T. I think I don't even use this. Use this. Kind of left. We do not use this anymore. Okay, this will be for the initial layer to get into cover. So when you find a cover, you have to make sure you are on the correct position. So we will use this over there and nothing else. Move positive if we are moving on. Basically, it helps the animator if we are moving towards the right or left. Cover movement speed, 2-point validation, I said what it is. If we want to debug our cover, and we have a debug cube, and if it's also crouch cover, and our relative input is basically our input. So on init, we update states, we create a new cover position. This is a class, it's not a mono behavior, so you do not have to assign it on your game object. We create a new one on start, or init in this case. Okay, we create a new game object for the helper name. We also name cover helper, and we have our ignore layers. Okay, game object.layer is the layer that we have our player. We do not want our raycast to find our player as a cover. Okay, logically. So the first layer is the layer of the player. 3 is the ignore layer Unity has by default, so you might want to include that. And 10 in my case is a layer I made just for props. So everything that has to do with pickables, the trigger colliders for the executions and all that, okay, will go under props, or the execution might go into another collider if you have problems with them. Okay, so basically everything that has to do with props. And the player collider is on the layer controllers, so basically 10 and 11 should be ignored. If we want to debug, we create a new primitive, we change the scale, and we also, Unity by default on primitives, it creates box colliders or creates colliders for them. Of course, we do not want to have a collider on a primitive, so we just destroy the collider. Minimum cover, as I said, 0.2, offset from wall 0.6, sample distance 0.25. Of course, you need to set all this up for your own controllers and what you think it works best for you. On tick, if we are searching for cover, okay, if we're not, then we are on the TPS controller as normally, so basically ignores all this. Okay, if you are searching for cover and you do not have cover, we do a raycast for cover. The origin of the raycast will be our own position plus half a point up, so 0.5, and we want to start a little bit below us so we know what we can hit, because if you start raycasting from the transfer position of your player, it might be at the same level as another collider, so yeah, you won't be hitting any colliders. Okay, sometimes you might, sometimes you might not. So we just go a little bit further back and raycast find targets. Our direction, of course, will be transfer.forward. We're going to do a raycast hit, float distance, ahead distance, how far ahead we want to have. I have it at 3. So we're doing a raycast with our origin, the direction, out hit, the distance, and our ignore layers. If we hit a box collider, we place our helper transform with a position with offset. Okay, this is a function that you pass an origin and a target. It's going to find the direction between origin and target. Notice the order from origin to target. We normalized, of course. It's going to offset it, direction multiplied by our offset from wall, and the return value will be the target position plus the offset. Okay, the order is important over here, and it's going to return that position. So this will return us a position from the collider we just hit a little bit further back. Transfer rotation will be the hit dot normal. Okay, hit dot normal is the direction, so you only have to turn it into a quaternion. And we want the opposite of the normal, because the normal, if you hit a normal like this, the normal of this collider you see over here looks by this. We want to look inside our cover, so we will use like this. So if this is a valid cover from right and left, this is an encapsulated function. What it does, takes the transform, the helper, and if you want to raycast, if you are raycasting from the right or the left position, basically, return a value right. If you want to raycast on the right, okay, you say the right of your helper, otherwise the opposite. We multiply that by a minimum cover, so it doesn't go, it goes like 0.5, or no, I think it's 0.2 minimum cover, what we have over here. Yeah, 0.2. Okay, and we also add the helper's transfer position plus the site minus on the opposite minus transfer.forward, the origin. So it's a little bit further back than where we actually placed our helper. And of course the direction will be transfer forward, which is looking towards the wall. We do a raycast. We also have a backdraw array. We do a raycast by origin and side. This is the first raycast that looks towards if you have a wall over here. If you have a wall over here, that means it's not a valid cover, of course, because there is a wall. And if it doesn't find anything on your minimum cover we have over here, then it's going to see if it finds a box collider ahead of him. So we need another raycast hit. This time we'll name it towards. We add on our origin plus our side. So this time we are raycasting from this position instead of the normal one. Okay, if origin, direction, towards the ahead distance and the ignore layers. And if we find a box collider, then return value will be true, and if we are moving right or left, we will be assigning on our cover position, our new cover positions, position 2 and position 1, the position with offset. We pass the origin and we pass towards the point. Okay, if this also doesn't hit anything, then return false and return the return value. We do this for both left and right, and if both are hit, that means it's at least the minimum size, the cover is at least a minimum size. So we say we have cover, and we also need to save the initial hit for the cover position. Okay, hit that point. So we are over here, we have found the cover, so we have a cover. If we have debug cover or not, if we have the debug you created it basically, it's going to place it on the same position as our helper and the same rotation. Okay, if we haven't yet initialized the cover, so we just found the cover, we want to get into cover. Disable controller, it goes on the states, goes to the DAM model and enables it, and finds the collider of the controller and makes it into a trigger. So because we have a trigger collider now, that means we have to freeze the position of a rigid body, and we do that on the freeze position Y. Okay, states in cover equals true, that means we are now in cover. So we disable the controller, that means all the functions we have on our state manager, all the ticks we have over here, will not run. Of course we want some of them to run, but we will see this in a bit. Okay, so it's basically a dummy model, it doesn't do anything now, and enables the get in cover lerp. Get in cover lerp, it's just a lerp. Okay, we find the length, and here's why we need position 1, position 2. It finds the length between the minimum cover. Well, we know what is the length basically since it's a minimum cover, but yeah, let's just be safe. It finds the hit distance between the initial hit and the first position. It's going to find the cover percentage by hit distance subdivided by the length. Okay, the target position will be a position on a lerp. Well, basically the percentage between lerping from position 1 to position 2. Okay, it's going to be the percentage we find from over here. And the starting position, of course, is going to be our transform load position. We initialize the lerp, we set the T to 0. If it's a crouch cover, if it's a cover that is, you can only crouch behind, or if it's a cover that it's like this, we handle this over here. Is cover full, is basically doing gets a helper position plus a vector 3 up. The direction will be where the helper is looking, of course. Does a raycast, and it's just one, it doesn't need to be this extreme or more extreme than this. And if it finds a box collider, it's going to return true, and it's also going to update the crouch cover on the states. Okay, and returns the variable. Okay, if it's crouch cover, then it's going to say on the states crouching equals crouch cover. Cover direction, let's just set it to 1. Everything that is not 0 is better. So we have initialized a lerp. We now start the lerp. Okay, movement, lerp speed multiplied by our own delta. Lerp movement subdivided by the length, and we add that to our T. If the T is higher than 1, set that to 1, and you have already initialized the cover. A vector 3 lerp, start position, target position, and T, and we need to override the Y to be the same as our own transform position Y, and we assign that into our transform position. Okay, we need to assign we need to override the Y because the helper is a bit off the ground, so it's not hitting. Otherwise your player should be about this height, and you do not want that. And of course we need to make sure that our player is looking the same way as our helper transform. Okay, yeah, from the side of the animator I didn't change anything, so it's going to be exactly the way we had it before. Okay, we have alert, we have get inside cover, so that means we have all the functions we want to use. So, handle shooting, IK handler, audio manager, and weapon manager, all this stuff work independently by our character movement script, and that's why we keep them on different scripts also. Okay, I hope now it makes a little bit more sense why we're using ticks instead of the regular update. And we have our handle cover movement, how we move inside our cover. Handle cover movement. Relative input X and relative input Z is our stage vertical and our stage horizontal. Okay, this is not tailored only for input, only for game objects that have input handler. This will also work for enemies with a few changes, of course. So, relative input Z, if it's lower than 0, then that means the player presses the bug, so that means he wants to get out of cover, or you might want to assign this into a different input. Okay, I'm going to leave it entirely up to you. I'll just have it as Z. And if we do that, we're going to call the function enable controller. So basically just reset everything, reset the constraints, set your trigger your collider to not be a trigger, reset the constraints to none, but you also need to, because Unity doesn't have rigid body constraints, unfreeze, as far as I know, of course. You have to refreeze on the rotation Z and on the rotation X. Okay, has cover false, search for cover false. We start the coroutine, enable search for cover. We will see what this is. Stage in cover false, and you update some values on your animator, like stage in cover, cover direction, crouch cover. We just pass it, and we also handle the handle animation the tick common, so it runs what it needs to run on a normal update. And enable search for cover basically waits for 0.3, so when you just got out of cover, you're not sticking up to cover once again. Okay, it's going to enable the search for cover after a little bit. So, if relative input X is not equal to 0, then that means we are moving or we're pressing a button. We need to see if we want to move positive or to the right or the left. Relative input X, if it's higher than 0, then that means we are moving right. Stage cover direction will be, if we're moving positive, will be 1, otherwise it's going to be -1. We're still looking if we are crouch cover, because you might have cover that it's like this. Okay, so you need to crouch over here, and you need to you can stay up. I don't know this collider where it is. Let's see if this is going to work. Okay, we have one collider over here, we have the other. Let's hit play. And it worked like butter. Okay, I'm not pressing any button to crouch. He just crouched by himself. Okay, crouch cover. If we are in a crouch cover, then hardcode the crouching to be to be always true basically. So if it's cover, so where we want to move is cover, can move on side, move positive. This is somewhat similar to is cover valid. We pass if we are moving right or left, and a little bit of offset where we initialize it as 0 basically. We start with a return value of false. We find the direction we want to move, right or left. We find the side will be now multiplied by our sample distance plus any offset we might have over here, and you will see where this is used. Our origin will also be our transfer position plus side, so we are recasting from a little bit the size of our player. We add to our origin a little bit up, otherwise we might be hitting the floor and we do not want to hit the floor. The direction will be the helper's orientation, recast hit. If we find a wall towards our side, then that means we cannot move. If we do not, then we do another recast inside towards the direction will be towards where the helper is looking. Okay, so basically, as I said, if this was over here, okay, it's going to do a recast towards the this is also orientated wrong, but anyway, doesn't matter. You see, it didn't give any errors. So if you are over here, it's going to recast to see if there is a wall over here, and if it's not a wall over here, then it's going to start recasting towards your box collider. Okay, if it finds a box collider, then the angle should be this. You will check the angle between the helper forward and the opposite of your normal, and if it's lower than 45, then that means return value is true. Place the helper position there with offset, and also rotate it to have the opposite of your normal. And I just noticed that we also do not check the height of the cover, but you can handle that by just raising, by changing this basically. Okay, if you change this, then the recast will go higher than this length. So, they will recast. If it's like this, the recast go above him, so it doesn't find a collider. Okay, I'm going to leave it up to you if you want to handle that way. Okay, and if it doesn't find anything, then that means you either do not have there's no more box collider left to it, or the angle is higher than this, so you cannot move there. And we are okay. If we can move, if we have enabled 2-point validation, if the first time we hit it is false, then it's going to do it again, but this time it's going to add a 0.1 offset, so it recasts further bit away to see if it can find a box collider. We need to find the target direction between our helper position and our own transfer position. Of course, we need to normalize that, and our target direction will be multiplied by the absolute value where we have on our x into our relative input. Of course, this is the horizontal that we have on our state manager. Okay, and if there is no cover, we disable our target direction, so we set it vector3.0, and we set our relative input.x to also be 0, so there is no input. And what you can also do over here is disable the rigid body. Disable the velocity of the rigid body. However, I didn't, because it worked a little bit better with bumps like this, as I said. So you have to keep in mind because you are moving with forces. Okay, when you are moving towards an edge, notice where the box is going to stop and notice where the character is going to stop. Okay, this happens because we are moving with forces. So the rigid body, it takes a little bit of time to adjust before it can actually stop. Okay, but this also works in cases like this where you have to be very careful to hit an edge. So if you are blazing through it, it doesn't matter, it's not even going to stop. The change on the velocity is going to be very insignificant. So I like it this way, so I kept it like this. If you do not want to use this, just disable the velocity of your rigid body in here. If we are aiming at sides, it's going to be controlled if it's covered or not, so we want the opposite. If the is cover is false, then that means we are on an edge. So you can actually aim from the sides. And if you can aim, will be controlled by aim at sides or not. And then we have on our character movement, you see, even if I do not run the update of the character movement, I still can access the rigid body because we have all this stuff public. We add force, the target direction multiplied by a cover movement speed. Okay, so we're basically moving towards the helper position and do not move towards where the orientation will be towards the helper's position. Our target rotation will be the same as our helper, and we do a lerp, and it should probably use my delta over here. Okay, if you want to have this to rotate only when you're moving, I suggest just keep it like this with the delta. I think it works a little bit better because if you just got into cover or you stop pressing a button before he rotated completely, then it's going to look awkward and it won't look that good. Okay, this will handle the rotation. Handle cover animation. We need to pass the input, and I intentionally did this. And the handle cover animation, if you are moving forward or not, it's going to take the absolute value of the input X or the relative input. Okay, and it's going to pass it on your animator. Cover stays in cover. Cover direction will be whatever we have on our cover direction. Crouch to up aim, if you can aim if you are up. States crouch cover. And the tick common we have on our handle animation. Okay, so basically that's all we have to do. Yeah, I think we covered everything. So this way is way more dynamic, as you can guess, and you do not have to worry about placing positions and all that. Just place box colliders, and I actually want to try moving from the inwards of this position. Just place box colliders. Okay, and just create your level with box colliders basically. And if you find anything else, we're also going to refactor the camera a bit because I don't like some clamping it does or stuff like this that it does. We're going to fix that on probably the next video or the video after that, we'll see. Okay, and we're also going to handle the it doesn't even compare to what we had before. This is way better and way more fluid, as you can see. Okay, and works with all your weapons. So I'm going to end the video here. Of course, by now you know what to do. Like, subscribe, and if you also like the work we're doing over here and you want to see it continued, of course, then consider supporting me either through Patreon or Gumroad, and I'll see you next time.